So I hope all of you have understood this design of counters, right? Have you all understood how we have designed this? Is there any doubts? Then we can have a revision on this. Any doubts, please feel free to ask. Yes, is there any doubts? Have you all understood how to do it?
Yes, sir.
Okay, then I had given you all an exercise to do, right? In order to, instead of using JK, I told you to use SR flip-flop, right? Have you all done it? Yes, no? Have you all done it or not?
We're not sure of the K map.
Not sure of the K map? Okay, have you worked it out? We can just verify the answers.
Sir, I've written like K map for SA and RA, others separate.
I didn't get you. Be loud, please. K map for?
K map for SARA, sir. Only for that test of flip flop I did. For PNC, I haven't done.
Okay, okay. So you're yet to continue, right? Okay, fine then.
Yes, sir.
How about the others? Nikita, have you finished it? Nikita MS,
Yes, sir.
have you finished it?
No, sir, I have to still do it.
Okay then. So this class we will take it as an exercise, okay, and we will try and complete the SR flip-flop implementation. Okay, once you are done, just let me know, and we will cross verify if these answers are correct. Is that fine, all of you?
Yes, sir.
Okay. Can one of you confirm if Swati's answers are correct for SA, RA, SP, RB, SC, RC? Okay. Rohit, what have you got for SA?
SA, sir.
Now, because of which here the vicinity we are having these two capacitors, and I told you the current contribution towards the spark will be released. Actually, that you can observe.
ECA.
Sorry, how much is it? How much is it?
And you can observe that the current to the spark is very negligible. Okay. So almost all the current will be flowing through this particular path.
What's the answer? I couldn't hear for SA.
A bar BCX, sir.
Okay, then for RA?
And also initially we have 10 volt echoes.
ABCX.
SB?
B bar CX, sir.
Okay, then RB?
BCX.
SC?
C bar X, sir.
RC?
CX.
Okay, fine. Rest of you try to complete it and come out with the diagram. Swati, have you finished the diagram? Swati K?
Which diagram? I have just completed K map, sir.
K map, okay, yeah. So come out with the final diagram and then we will get back.
Sir.
Okay, fine.
Okay, sir.
Most of you are able to get till the equation part, till the K maps. After that, you are a little confused as to how to implement the circuitry. So we'll get back to that in a while. So by now, I think you know how to, get the state diagram, okay, without any confusion, right? Okay. So once you have the state diagram, the table is just the representation, just that, whatever values are here, okay, you are just putting it in the form of tabulation. Okay. Now in this tabulation, do you have any doubt how we got this tabulation? Students, if you have doubt, please ask. Any doubts here?
No doubt, sir.
Okay, fine. So once we have the present state and the next state, okay, we decided based on the input, okay, like how we discussed yesterday. So if it's 1, if the clock is 1, then 0 goes to 1, okay, and 1 goes to 2, okay. So that was discussed yesterday. So based on the question, okay, sometimes in your question I would ask given T flip-flop. So in that case, you will have to use the excitation table for your T flip-flop. How will you do the excitation table? Okay, you have seen it previously, right? Wherein I had explained about, yeah, wherein I had explained about, the circuit and the characteristic table and the excitation table. So this is how you get it, right? Okay. So once you have the excitation table, okay, then you have to map things. Okay, so when I say map things, let me just make it a little small, become easy for you to understand. Yeah. So you will have to compare the value of A with A plus, okay, and the value of B with B plus, and the value of C with C plus, okay. So only those columns you will have to check. For example, here A is 0, okay, and then here A plus is 0. So for inputs 0, 0, I will be checking for the first one, which is 0, don't care, right? So here I'll be putting 0, don't care. So like this, you'll have to check the values for all the entries. Okay, right. Now, once we have these values filled, okay, we will be taking the K-map, and from K-map, we are getting these equations. I think till here, most of you are getting it right, okay, till the equation part. Now the confusion for you is only with respect to the implementation. Okay, so what I suggest you is first you check for multiplications here. Okay, you have BCX in common, right? Then you have CX in common, and then you have X. So if I have to multiply something, then that happens only through AND gate, isn't it? Through AND gate. So I will make sure that I get a combination like this, first CX, first X, then CX, then BCX. Okay. So X, I get it here. Okay. So X, I will give a single input. So this X is done. So which means JC and KC is taken care. So this goes to KC and the same X goes to JC. Okay. So initially what you'll be doing, you'll be just putting flip-flop. Okay. And in this flip-flop, you'll be having J, K, and your outputs. Okay. Since these are flip-flops, what I will do is I'll name them as A, B, and C. Okay, right. Now next we'll have to look for CX. So CX happens only when I multiply X with C, and that happens with the help of AND gate. So which means this is my CX. So CX is here. This is also done. Now CX should be multiplied with what? B. So B I will give as my input. So this output, okay, is fed to KA and J, right? So JA is also BCX, K is also DCX. So in that way, I can give my inputs to separate flip-flops. Okay, and ultimately, once this happens, okay, you can give a common clock. Okay, you can give a common clock and connect them to the various flip-flops. Okay. So it will be a common line. It will be a common line. Okay. So any doubts here, students, as to how we have implemented it? If any doubts, please ask me. Have you all understood it?
Yes, sir.
Have you all understood? Yes. Fine then. So next, what you can do is, okay, for your other workouts, I will want you to implement the same question for the remaining flip-flops. What are the remaining flip-flops? We have D and we have T. Okay. So here I will have DA. Okay, I will have DB, and then I will have what? DC. Similarly, TA, TB, and TC. Okay. So instead of JK, we'll be having just one alphabet here, which is D and T. Is that clear, students? So try to do this, okay, and we will see how it will work out. Fine. So can we end the lecture today?
So the SR flip-flop has S and R flip-flop different equations. So how would that come, sir?
Which one? S and R.
Yes, sir. Because here J and K have the same equation.
Correct. In that case, what you have to do, you have to use a different gates. That's it. Ultimately, make sure that you are getting this equation, whatever is the equation, right? Whatever is your equation, ultimately make sure that you are getting that equation with the help of AND gate or OR gate. Of course, you do not have any OR gate. In this example, you will be using only AND gate. And you want an inverter, okay, you have bar also, right? So for that case, you can use an inverter. Simple, right?
So I'm getting 6 AND gates. It's okay, no, sir?
See, it's not about how many AND gates. It's about implementing the circuit. Okay. So here we are not talking of optimization. We are talking of implementation, right? So which means, see here I have three different types. Okay. So CX is one kind of multiplication. BCX is another kind of multiplication. So which means I will have to use how many? One here and then two. Two AND gates is a must, right? So that is what is here. CX is the second AND gate. Okay. And this is my first AND gate, BCX. Right. Understood?
Yes, sir. Yes.
Okay. Now try to do for your D and T flip-flop. Okay. And we will try and see as to how this gets implemented. If it's going to be a little tricky, okay, with D and T, because you'll have to check with different values. Okay. So try and do it. Let us see how we can continue with that. Fine. Shall we end our session today?
Yes, sir.
Okay then. Yeah. I'll be sharing in the link. Okay. It's just